every language has some decision making statements. C language also has. There are different type of decision making like if statement, if else statement, if else if ladder, and also switch statement. Okay, let us go through them one by one. If statement. Okay, so the syntax is as follows, like if test expression, and then certain statements are there, and these statements has to be put in like in curly braces. If only just a single statement is present, then you can just write it without curly braces. Okay, so the flowchart is that if the expression which is present in this parenthesis, if it is true, like only if when it is true, the statements present in this block will be executed, or else it will not be executed. You see, like here int test is equal to 5. Is 5 less than 10? Yes, it is. So this set of codes will be executed. But what if the expression is test is greater than 10? So it is like 5 is greater than 10. It is false, right? So these set of statements will not be executed, and directly the control will come from the if statement to the next statement. Okay. So let us go through one example. This is an example program to display number if it is negative. Okay, like for example in these two lines we are asking the user to enter a number. Okay, the user enters -2, then here we are checking whether it is negative or not. -2 is less than 0. It is true, right? So we are printing the number that you entered -2. Printf if statement is easy. It's simple, right? So because of this easy and simple syntax, C language is widely used. If else statement. Okay, so what if the expression in which is present in the parenthesis of the if statement is false? Okay, directly the control comes out of the if statement, but in this case if else statement, the control will go to the else block. Okay, so if the test expression is true, then the if block will be executed, but if the expression is false, then the control will come to the else block, and else block will be executed. Okay, it will directly skip the if block. So here is an example to check whether the whether an integer is even or odd. Okay, so here we are asking the user to enter an integer. He has entered 7. So we are checking like 7 modulo 2 equal 0. Like why we are performing modulo operation? Because for an even number it has to be completely divisible by 2, right? So the remainder will be 0. So if the number when divided by 2, the remainder we are getting 0, then it is even number, right? So number modulo 2 equal 0. If it is true, then printf even integer, else printf it is an odd integer. If else ladder. What if we don't have like only two conditions, like if this statement is true, then perform this, if it is false, perform this. Instead of that, if we have several conditions, then we need to make use of if else ladder. Okay, the syntax is like this: if test expression certain codes, else if another test expression certain codes, else if another test expression and certain codes. Like that it will continue, and there will be a last else block. Okay, so what is the speciality in this if else ladder is that whenever the control finds that a particular test expression is true, it will execute that particular block and skip the remaining block. Okay, for example, you see, if the test expression 1 is false, then only then it will go to else if the test expression 2. But if it is true, it will directly skip and come to out of the if else if ladder. Okay, so if it is false, so it comes to the test expression 2. It checks if that comes out to be true, then it will skip all these remaining statements and it will come out of the if else if ladder. Okay, so here is an example where we are checking whether two numbers are equal or one is greater and another is less. Like here there are three conditions, right? So first condition is if number 1 is equal number 2, else if number 1 is greater than number 2, else I mean the third case is denoting that the number 1 is less than number 2. Okay, so in case of multiple decisions, okay, we need to make use of if else ladder. Instead of this if else ladder, we can also make use of switch statement. Okay, but the thing is that in this switch statement, the expression, okay, the argument of the switch statement can only be integer or char. Okay, only these two are allowed. But in if else ladder, anything can be allowed. Okay, it just depends whether the test expression is true or not. Okay, so in this, characters can also be passed. Okay, but in here characters cannot be passed. Like every character has the value from 0 to 255, except the character which is having the ASCII value 0. If any character is written in the like test expression, it will treat it as true only. Okay, and execute that block itself. So that is the demerit. So in such case you can make use of switch statement. Okay, it actually tests the value of this expression, whether it is equal to the case value 1 or case value 2 or case value 3, so on. Which case value if the expression becomes equal to the case value, then it will like execute that particular code block and come out of the switch statement. And for coming out of this switch statement, we make use of break statement. Okay, but what happens, like what if all the cases they return the value false? Okay, so in such a case there will be something called as default block. Okay, in that default statements will be executed and the switch statement will end. Okay, so let's go through an example. This is a calculator program. We are asking the user to enter an operator. Okay, so that operator we are passing it to the switch statement. Okay, so switch statement verifies whether it is a plus, minus, into, or division. So accordingly it is performing the required actions, like for plus n1 plus n2, for minus n1 minus n2, and then printing the results. Okay, so here is the output, like enter an operator. When the user is entering minus, it is asking like enter two operands, 32.5 and 12.4. So you perform this subtraction, we are getting 20.1. The compiler also returns the value 20.1. Okay, so this is how switch statement is working. Now coming to the loops. Okay, C language, what happens if we need to like run set of lines multiple times based on some conditions, then we make use of loops. Okay, in C language there are three different type of loops: for loop, while loop, and do while loop. Okay, when the number of times we need to run, like if the number of iterations are known to us, only then we make use of for loop. Okay, the like flow chart is there will be an initial expression and followed by a condition. Okay, condition is the test expression. If it is true, only then the loop body will be executed and the expression will be updated, and then once again condition will be checked. But see, after updating the expression, the control never goes to the initial expression. This you need to keep in mind. Okay, when the condition becomes false, it comes out of the loop statement. So here is a simple program to print the natural numbers from 1 to 10. Initial expression is I equal to 1. The condition is I is less than 11. Instead of this, I could have also written I is less than equal to 10. That can also work. Okay, update expression is plus plus I. Instead of this, you can also write I equal to I plus 1. Okay, no worries, it will work. Okay, so this is how for loop works. First is initial expression, then condition, then update expression. Okay, and the loop, like all the statements for the body of loop, you need to give a curly braces. Okay, when is while loop? Okay, when is while loop used? When you do not know how many times you are going to iterate. Okay, in such case while loop is used. Okay, so while test expression, a while is doesn't have any initial expression. For the initial expression has to be written prior to the while loop. Okay, so the test expression, the condition will be tested. If true, while loop executed, and if it is having some update expression within that, then it will be checking, or else will gets or else it will be keep on checking the conditions only. Okay, like whenever the condition is false will come out of the loop statement. Okay, here is also the same program, like printing the numbers from 1 to 5 instead of 1 to 10 using while loop. Okay, here see, this is the initial expression. It is not included in the loop, but yes, update expression is present. Depending on the application, update expression may or may not be present. Okay, so while I is less than equal to 5 until 5, okay, it denotes until 5. Until I value changes from 1 to 5, we need to print the value. Since slash n is given, the values are printed in line by line. So do while. Okay, the speciality of do while is that it is an exit control loop. Okay, like do in for loop and while loop, only if the condition is true the body of the loop will be executed. Okay, but in do while, even if the condition is false, at least once the loop body will be executed. This is because you see the syntax. Okay, first the statement is executed and then you're checking the condition. Okay, while test expression, so the condition is checked after execution. So it is referred to as exit control loop. But for in case of for loop and while loop, the condition is checked before entering the loop body. That's why it is said entry control loop. Okay, this is the main difference. So like here is a program to add all the numbers until the user enters 0. Okay, do like at least once the program will run while number is not equal 0, like not equal to 0. It will keep on running these set of statements. Okay, and then find the sum. Okay, whenever the user enters 0, it will return the sum up to that number. Okay, so 1.5, 2.4 minus 3.4 plus 4.2, the answer is 4.7. Okay, this was all about the loops. And yeah, there are two different statements which are most widely used in loops: break statement and continue statement. Okay, so both are used to skip certain part of the code within the loop. Okay, break is used to come out of the loop, while continue is used to skip a certain part and go to the update expression. Okay, or once again iterate the loop. Okay, so break expression, the syntax, like whenever the statement is used, the codes following that will be skipped and the control will come out of the loop. Okay, so let's see an example. This is an example to calculate the sum of the numbers. Okay, maximum 10 numbers. But like whenever the user is entering a negative number, we are terminating the loop. Okay, so the loop is iterated from like I equal to 1 to 10, because maximum 10 numbers. Okay, but we are breaking the loop, like if number is less than 0, we are breaking the loop. Okay, so here you see n1, n2, n3, these are positives, but n4 is negative. So here the loop is broken, and this statement sum plus equal to number, this minus 3 is not added to this sum, and the answer we are receiving is 10.30. That is same as 2.4 plus 4.5 plus 3.4. Minus 3 is not added. This statement after the break has been omitted or skipped. Okay, this is used to skip certain part of the loop based on some conditions. Okay, so continue statement skips the loop body, but only for that iteration. Okay, it takes the control to the next iteration, I mean to either to the update expression or directly to the condition. Okay, in case of for loop it goes to the update expression and then condition and then comes, but in case of while loop it directly goes to the condition. Okay, it tests whether once again the condition is true or not, test expression is checked. Okay, so here is the same program, but here what happens is that we are not. So here, yeah, the loop is run from I equal to 1 to I is less than equal to 10 because of 10 numbers max. Okay, so but whenever the user is entering a negative number, it is not added to the result. Okay, because when continue is used, the statement after the continue statement is skipped for that iteration. It doesn't take the control out of the loop statement, it takes the control to the conditions. Okay, so once again it tests the condition. If it is true, then the loop body is once again executed. Okay, so here we are asking the user to enter 10 different numbers, and whenever the user is entering like negative numbers, this statement is not executed. That is, the sum operation is not being performed. So we are getting the result as 59.7 as per the values entered by the user. Coming to functions, functions is a block of code. Okay, like mm, suppose the entire problem statement, I break the entire problem statement into smaller parts and write different codes for it. Like for example, here we can consider, like in I need to draw a circle and fill it with a color. Okay, in order to draw a circle I write a function, in order to fill a color I write another function. So what happens is that in this manner, if I write the code, it becomes easy to understand. Okay, and further I can reuse the code also. What if like I need to draw two circles and fill in two different colors? Okay, in that case I just need to call the functions two different times. Okay, no need to like repeat the set of codes once again to draw two circles and also fill them with two different colors. Okay, so functions are actually used in order to make the code modular, easy to understand, and also reuse the code. Okay, so here is an example where a function is written. Okay, this is the main function, it will be there in each and every program. This is the user defined function, add numbers. This performs the operation of adding two numbers a and b. Okay, and after adding it is returning the result. There are three different things here: function prototype, function call, and function definition. We'll be discussing about that. So what is a function prototype? Okay, function prototype is nothing but like declaration of the function. Okay, in this function prototype we'll be specifying what will be the return type of the function. Okay, and what is the function name and what all type of arguments it is going to take. Okay, it just gives the information to the compiler that yes, there is a function with a name this, and it has a return type of this, and is going to take arguments of this and this type. Okay, that's the information provided to the compiler. Okay, so actual details lies in the function definition. Okay, in the function definition also we need to specify the return type and argument types also. Okay, in there we need to write what all code that we need to put it as a function. Okay, the part of the program we need to like keep it in different modules, right? So that is actually the function definition. And in order to call this function, like in when we want to execute this set of statements, we need to call the function. Okay, the function can be called by the function name, and if arguments are present, then arguments need to be passed. Like, and also we need to keep in mind that this argument data type and the data type of the argument specified in the function prototype and function definition, all these have to match. Okay, or else it will throw an error. So how to pass the arguments to a function? You see, here is an example: int add numbers, int a, int b. This is the function prototype. Here I am passing two different variables n1 and n2. So n1 value is getting stored in the variable a, and 2 value is getting stored in the variable b, and then the set of code is set of statements are executed, and return statement is used, like after adding the numbers we need to return the result also. So this add numbers n1 and n2, this will call this function, perform the operations and return the result. That result can be stored in some variable, like here we are using sum equal to assignment operator is used in such cases. Okay, but yeah, there's one more thing, the arguments to a function can be passed in two different ways. Okay, one way is passed by value, another is passed by reference. For pass by reference we need to use pointers or arrays. Okay, in pass by reference what happens, we can modify the value of the variables which are passed as arguments. Okay, suppose n1 and n2 are passed by values, then the value present in the n1, that copy will be passed. Okay, but passed by reference means the actual variable address will be passed, and while changing the value present at that address, the value of n1 and n2 will also change. Okay, so this is the difference between pass by value and pass by reference. Later is, I mean, the second one is allowing us to change the values of the variable in other functions also. Okay, like n1 and n2 value we can change in these user defined function, provided they are passed by reference. Okay, like using pointers and n% operators. Okay, so on. So coming to recursion. Okay, what is recursive function? Whenever a function calls itself, then that function is known as recursive function, and this process is known as recursion. Okay, so you see here, in the main function we are calling the recurse function, and within the recurse function it is calling itself. So this is the recursive call and this is the main call. Yeah, this is a simple program finding the sum of natural numbers using recursion. Okay, so this is the main driver program. We are asking the user to enter a positive integer, like for example 3, and we'll find out the sum of all the natural numbers from 1 to that number. Okay, so we are calling the function sum, like we have written a user defined function sum which takes the argument of integer type and also returns the value of integer type. So in order to easily understand this recursive function, let's go through this flow. Okay, first the control comes to the main function. In main function the sum is called and 3 is passed, so it checks 3 is not equal to 0. So 3, it performs return 3 plus, once again sum is called, but here 2 is passed. So once again 2 comes here, 2 is decremented, like 2 becomes 1 and 1 is passed, then 1 is decremented, 0 is passed. So 0 not equal to 0, it is false, so directly 0 is returned. Then 0 is added to 1, 1 is returned, 1 is added to 2, 2 is returned, then 2 is added with our what yeah sorry, 0 is added with 1 and then 1 is added with 2, we get 3, right? So 2 plus 1 equal to 3 is written, and then when 3 is added with 3 we get 6. That's why the sum obtained is 6. In this manner recursion works. So yeah, this is the last topic, arrays. Okay, array is a variable which is capable of storing multiple values, but all the values which the array can store, it has to be of the same data type only. Okay, suppose if you want to store 100 integers, we can create an integer array. Okay, int data 100. So data is an array of integer data type and it can store 100 integer values. Okay, one specialty is that all the values that are stored in arrays, they are stored in contiguous manner, consecutively they are stored. First value, if it is stored in memory location 1000, okay, then the next value will be stored in memory location 1001 if the like size of the data type is 1. Okay, then 1002, then 1003, then 1004. In contiguous manner all the values of the array are stored. Okay, there are also four different things that you need to remember about array. First is declaration of array. Okay, you need to specify the data type, array name, and the array size. Okay, so here float mark 5 means mark is a array of floating point type and size is 5 and it can store 5 floating point values. Okay, so how am I going to access those floating point values? Like, see, you can imagine like the array elements are arranged in the form of cells, and the indexing array actually starts from 0. Okay, in Python, Python also the indexing starts in 0. C language also indexing starts with 0, but yeah, Python provides indexing from the right side also. Like here, 4 refers to indexing as -1, then 3 as -2, but in C language only positive indexing is allowed. Okay, so if the array size is 5 and indexing starts from 0, so the maximum element, like the maximum number will be 4, because 0 to 4 means 5 numbers, right? So how to initialize array elements? Okay, while initializing we can write the values directly, like comma separated values, and enclose them in curly braces. While initialization we can either specify the size or not specify the size, like it's depending upon the programmer. Okay, so here 19, 10, 8, 17, 9 they are stored in contiguous manner, and using the indices 0 to 4 we can access them. So what about changing the value of the array elements? Yes, they are possible. Okay, so mark 2 equal to -1. Okay, what this statement does is that it goes to the 2 location. Okay, location 2 means 0, 1, 2, third element. Okay, this 8 will be replaced by -1. And then the next statement, mark 4 is equal to 0. So mark 4 means the last number. Okay, so 9 will be replaced by 0. After that, if I try to print the array, then I'll get 19, 10, -1, 17 and 0. Okay, so this was about the array. Let's go through an example. Okay, so this is an example program to find the average of n numbers using arrays. Okay, so yeah, I'm declaring an integer array of size 10. Okay, and running a loop from I equal to 0 to I is less than n. So n is the number of elements. Okay, so number of elements that here the user have to enter less than 10, because the maximum array size can only be 10 only, right? So even if the user enters 11, that cannot be stored in that array. Okay, so yeah, so, here the user has entered 5, so the loop will run from 0 to 5 times, right? So number 1, number 2, number 3, number 4, number 5. So these are the respective numbers, and then we keep on adding them and storing the result in sum. So the average is nothing but sum divided by number of digits and number of integers, right? So here the number of integers is n, so sum when divided by n we get the average. And here for percentage the integer specifier format specifier is used, so we get 39. Okay, had it been floating point specifier, so we might have got 39 point something. Okay, so yeah, one thing we need to keep in mind is that we should never access the elements beyond the array size. Like, we can access, but that will result in unexpected output and the behavior is not undefined. Like for if you run the program now, you can get some value that is actually garbage value. Okay, if I'm trying to print array of 11, mark of 11, then I'll get some garbage value. Once again, if I run, then I may get some other garbage value. Okay, so that is undefined behavior. So like, we can access the array element beyond the size. Okay, but we should never access that because of unexpected output. Okay, So that was all about C language and its basic. We'll also be giving you some questions, some programs which you can try on. Okay, either you can try it on or by installing the compiler, or you can make use of the online compiler also. Okay, like it is up to you. You can like online compiler is easy, nothing difficult. Just open that link, write it there itself and run the program also. Okay, you can get the output. So that was all about C language. We'll meet in the next module. Yeah, thank you.